Okay. So, uh, if you have any questions, please put in the chat. Uh, since I connected to this mic, I want you to listen if you are saying anything to the mic. Okay. So, I'll quickly briefly explain what we did in the last class. So, we started fractions in the last class. Okay, and then fractions we have three types. Okay, proper fractions. So where the numerator is smaller than the denominator, 3/5. And improper fraction. Improper fraction. So for example, 7/4. In improper fraction, the numerator is bigger than the denominator, and also we have mixed number. So here the fraction is mixed with the numbers. For example, 3/2, 4, 2, 5, etc. So here also the in the fraction part, the numerator is smaller than the denominator. Okay. So we have three types of fractions: fraction, improper fraction, mixed number. And we studied how to convert improper fraction to a mixed fraction. So 4 into 1 and another 3. Okay. Another example, 8/5. So 5 into 1 and here 3. Or we have 7 to 2 into 3. The denominator doesn't change. It will be the same, remains the same as this. And 2 into 3, 6 remains 1. Also, we discussed how to convert a mixed number to a improper fraction. So here 2 into 3, 6, 6 plus 1, 7, 7 half. 5 into 4, 20, 20 plus 2, 22/5. Right? And then we studied uh, unit fractions. So unit fractions we have 1/2, 1/5, 1/7, 1/100, 1/222, 1/1005. So anything 1/. The numerator is 1 and denominator can take any value. So these are unit fractions. They are in the numerator you have 1. Okay. And then we discussed equivalent fractions. Right. Also we studied equivalent fraction. For example, 7/13. We can write a equivalent fraction. If multiplied by 2, 7 into 2 is 14. So if I multiply numerator by 2, then denominator also should multiply by 2. So 13 into 2 is 26. Another example, let's say 1/3. So here I can multiply this by 4. So 1 into 4, 4. 3 into 4, 12. Or if we have something like 15/20, we can write a equivalent fraction. Divide by 5, you have 3. Divide by 5, you have 4. And these are equivalent fraction, but the special thing about this is this fraction is written in the simplest form, right? So we discuss how to write a equivalent fraction in a simplest form, right? To write in the simplest form, for example, let's say 12 over 15. If you want to write the simplest form of this, we want to first find the highest common factor. Highest common factor. The highest common factor of these two, 12 and 15 is 3. Then you have to divide by 3. So if you divide by 3, you get 4, you have 5. So 4 over 5. Also, I explained you how to find the highest common factor. If you have still doubt, you can go and check the previous video, which I have already shared in the group. Okay. So those are things that we discussed in the previous class. Also, we studied prime numbers, and the prime numbers we studied because we want to find the LCM, least common multiple. For example, now if we have a addition 1 over 4 plus 3, let's say 1 over 7 plus 3 over 7. So here the denominators are same. So therefore we can take the common denominator 7, 1 plus 3, it will be 4 over 7. So such addition or subtractions are easy. Now I'll take one example from subtraction. 5 over 9 minus 4 over 9. So again, the common denominator is 9. So 5 minus 4, we get 1 over 9. So such addition subtraction is easy because the denominator is same. But what if we have a addition like this? 1 over 2 plus 2 over 3. So in this case, you can see the denominators are not equal. So in order to get the common denominator, what we have to do is we want to write the equivalent fraction for this and equivalent fraction for this so that their denominators are same. To find that, we had to find the LCM, least common multiple of 2 and 3. So the least common multiple of 2 and 3 is 6. Okay. So if anyone have any doubt what is common multiple, you can again check the previous video. So here then I have to multiply by 3. So this one also should multiply by 3 plus here you have to multiply by 2. Therefore this one also should multiply by 2. So here 2 into 2, 4. So I get 7 over 6, which we can write as a mixed number 1 over 6. Okay. So today what we are going to do is I will give some addition, subtraction, and also we will discuss few questions from multiplication and division, and then we will be doing question from the textbook. Okay. So first we will complete the review exercise and then we'll cover all the exercises, and then we'll do few questions from past papers as well. Okay. So after that we can move on to the next lesson, the unit 4. I think it is the binomial expressions. All right. So I'll give you 5 questions from addition and subtraction of fractions. Simplify. Question number 1. 7 over 5 plus 3 over 2. Second one. 2 over 3 minus 1 over 5. Third one. 2, 3, 4 plus 1 over 3 minus 9 minus 2 over 7. So, okay, so you have 4 questions. So do these 4 questions. This is 2. I'll give you each question 1 minute. So 4 minutes. No, 4 minutes is much. You have to complete one question less than. So I 3 minutes, and then I will start the explanation. It's 8:56. Okay, you have 2 more minutes. Okay, check whether your answers are correct. So the first one, 7 over 5 plus 3 over 2. The LCM of 5 and 2 is 10. So we take the common denominator in. To make this 10, we have to multiply by 2. So therefore, this one also, we have to multiply by 2. In equivalent fractions, we studied if you multiply the denominator by a number, the same number only you have to multiply the numerator. So the 7 into 2 is 14. 2 we have to multiply by 5. Therefore, this one also we have to multiply by 5. So 3 into 5, 15 plus 15. So we have 14 plus 15, 29 over 10. So if you want, you can convert this to a mixed number, 2, 9 over 10. Second one, 2 over 3 minus 1 over 5. So the LCM, least common multiple of 3 and 5 is 15. Since 3, 5 both are prime numbers, then they are, since these two are prime numbers, the LCM of these two is their multiplication. 3 into 5 is 15. Okay, the least common multiple of two prime numbers is their product. That means their multiplication. So 3 into 5 is 15. So you write 15. Okay. To make this 15, we have to multiply by 5. Therefore, numerator should multiply by 5. 2 into 5, 10 minus. This one we have to multiply by 3. Therefore, this one also we have to multiply by 3. So, minus 3. So, 10 minus 3 is 7. 7 over 15. So, the next question, question number 3. The first, we had to convert this mixed number to improper fraction. So, 4 into 2, 8. 8 plus 3 is 11. So 11 over 4 plus 1 over 3, 1 over 3 minus 2 over 7. So the LCM of 4 and 3 is 12. We know. So then we want to find the LCM of 4, 3 and 7. Since these two LCM is 12, so the LCM of 12 and 7 is, since 7 is a prime number, so you can get the multiplication. 7 into 12 is 84. So 84 is the LCM. 84, right? Okay. In order to get this 84, we have to multiply by 12. So this one also we have to multiply by 2 plus minus 2 into 12 is 2 into 12, 24. So here the 4 should multiply by, first it has to be multiplied by 3 to get 12, and then again multiply by 7. So 3 into 7, 21. This 4 we had to multiply by 21 because 21 into 4 is 84, right? So else simply you can divide this by 4 to get the number, right? So then here you have to multiply by 21. So therefore the numerator also you have to multiply by 21. So 21 into 11, 21 into 11. So multiplying by 11 is easy. You have to write 21 because 1 into 1, 1, 1 into 2, 2, 1 into 1, 1, 1 into 2, 2. So whenever I have to multiply by 11, I don't write this. I simply write the number first 21 and then shift one step 21. Now, for example, 35 into 11 is 35, 35, so 5, 8 to save the time. So because multiplying by 11 is easy. Okay, that is additional knowledge. So 231, 231. So here we get 231. 3 we had to multiply by 4 first and then multiply by 12. So 4 into 12 is 4 into 12, 4 into 12 is 36. Okay. So therefore this one we had to multiply by 36. No, I missed it. 3 into 4, 4 into 7. 4 into 7 is 4 into 28. So 28 into 3 is 8, right? So 84, you have to divide by 3. 3 into 2 is 6, remains 2. For 24, we have 28. So here we had to multiply by 28. So therefore, the numerator also we had to multiply by 28. So 1 into 28 is 28. So then now most of you what you will do is you add this two. But what I will do is actually for 28 minus 24, you get 4. So adding 4 for this is easy. But instead of adding 231 plus 28, it will take some time, right? So rather, you can take 231. And here if you subtract 4, 4 plus this 235 divided by 84. So you can leave the answer like this. Okay. Raise your hand if your answer is correct, because this is a little bit difficult one. Question number 3. Okay, I'll explain again. Raise your hand if you got this answer correct. All right. So here I'll explain it. First, you have to convert this mixed number to a improper fraction. That part is easy, you know. And then what you have this, right? 4, 3, and 7. So you want to find the LCM, least common multiple of this 4, 3, and 7. So we have, with good experience, you may know the LCM of 4 and 3 is 12, right? You know that is 12. Okay. So now we want to find the LCM of 12 and 7, because 4 and 3 is 12, and then now 12 and 7 is we want to find. So since this is a prime number, 7 is a prime number, so the LCM of these two is simply the multiplication. 12 into 7 is 84, right? Therefore, the LCM of 4, 3, and 7 is 84. This is the smallest number that you can get by multiplying in the multiplication of 7, 3, and 4, right? Okay. So LCM is 84. In order to get 84, this 4 should be multiplied by 21. Therefore, this one also you have to multiply by 21. So 21 into 21 is 100, 231. 231. Okay. And then to get 84, 3 has to be multiplied by 28. Okay. 3 should be multiplied by 28. If you can't get this directly, then how you can get this? Now, in order to make this 12, 3 should multiply by 4. And then it has to multiply by 7. So 4 into 7, 28. So 28. Therefore, the numerator also should multiply by 28. Okay. Right. So then next, this one you have to multiply by 12. Therefore, numerator also should multiply by 12. Then you get 2 into 12 is 24 minus 24. So then you can have to simplify this. So in rather adding this first you can subtract this. 84 minus 24 is 4. 4 plus 231 is 205. So that's the answer. Okay. So if you can do such a fraction addition, any question from addition can be done easily because you won't get this difficult in your exam, in your oral exam. Okay. Right. And the last one is bit C. So 3 into 1 is 3 and 5. 5 over 3 plus uh, here we have 3 over 5. The LCM of 3 and 5 is 15 because this is a prime number, this is also prime number. Therefore, its LCM is simply the multiplication 15. So here you multiply by 5, this one also should multiply by 5 into 5, 25 plus. This one we had to multiply by 3, therefore this one also we had to multiply by 3, 3 into 3, 9. Okay. So then we have 25 plus 9 is 34 divided by 15. So 2, 4, 15. Yes. Okay. Okay. Now let's do few questions for multiplication and division. So now for example, 12 over 5 multiplied by 15 over 4. Okay. 12 over 5 multiplied by 15 over 4. So when you have a multiplication question, right? So now what is this? This is a fraction, that means 12 divided by 5, right? And this is 5 divided by 4. So the the numbers which are in the bottom, it's dividing, right? It divides the number. So here what you can do is, before multiplying, you have to check whether anything that you can simplify. Now here 15 can be divided by 5. Yeah, so you can simplify that first. 5 into 1, 5 into 3. Or you can simply think 15 divided by 5 is 3. 12 divided by 4 is 3. So 3 into 3 now multiply is 9. Okay. Second one, 8 over 6 multiplied by 10 over 14. So then here again, now we can simplify this. 8 and 6 can divide by 2, so it will be 4 over 3. 8 divided by 2 is 4. This 6 divided by 2 is 3. Okay, I'll make this 9. It will be nice. And then now we have 9 over 14. So 3 into 1, 3 into 3. So here these 2 we can divide by 2. 2 into 2, 2 into 7. So we have in the numerator 2 into 3, 6. 1 into 7, 7. Okay. Okay, I hope it is clear, and I'll give you 3 questions from multiplication. 21 over 5 multiplied by 30 over 6. Number 4, and 3 to 5 is a mixed number multiplied by 3, 1, 2. So in such questions, first we have to convert the mixed number to the improper fraction. Okay, first you have to convert to the improper fractions, and then you can do the multiply. 5. Do these 3 questions first. Okay, check your answers are correct. So here we can simplify. The 30 divided by 5 is 6, and 6 and 6 cancel. So the answer is 21. Okay, and the next one. Here first we want to convert the uh, mixed number to improper fraction. So 5 into 3, 15, 15 plus 2, 5 into 3, 15, 15 plus 2, 17 over 5 multiplied by 3 into 1, 3, 3 plus 2, 5, 5 over 3. So this 5 and this 5 cancel. The answer is 17 over 3, and write as mixed number 3 into 5 plus 2. So here it's straightforward. There we can't simplify, right? So 1 into 3 is 3, 2 into 7 is 14. So 3 over 14 is the answer. Okay. If you have passed the grade 7 maths, means you can do these questions. There's only multiplication and division. And we'll see few questions from division. Division is nothing but it's a problem of multiplication first. Now, for example, let's say 4 over 3 divide by 1 over 3, right? So the division question we can uh, convert to a multiplication just simply taking the reciprocal of this one. The reciprocal means we are taking numerator to the denominator, denominator to the numerator. Okay. So this one is 4 over 3 and you take the reciprocal here. So division becomes multiplication 3 over 1. Always you have to take the value next right side to the division. Because in when correcting papers, some students they sometimes by mistakenly take this one. That is totally wrong. You have to take only the right side one. Okay. This one you have to take the reciprocal, so division becomes multiplication. Okay. So then 3 divided by 3 is 1. So 4 into 1 is 4 and the denominator is 1. So you can write as 4. Okay. Right. I'll give you a few questions on division. Okay, do these 3 questions. And I'll give one more. Okay, do these 5 questions. Okay, so I'll do this check whether your answers are correct. 3 over 5. You take the reciprocal of this, division becomes multiplication. 10 over 7. 5 into 1, 5 into 2. 3 into 2 is 6 over 7. Okay, so the next one, 25 over 17. You take the reciprocal of this, division becomes multiplication. 2 over 5. This 5 and this cancel. 25 divided by 5 is 5. So we have 5 into 2 is 10 over 17. 17. Okay, so here first we want to convert this into a improper fraction. So 6 over 10 divided by 5 into 2, 10, 12. 12 over 5. Okay, so then we have 6 divided by 10. The division becomes multiplication when you take the reciprocal. 5 over 12. So 6 into 1, 6 into 2, 5 into 1, 5 into 2. So the answer is 1 over 4. And the fourth one, that is very easy. So 2 divide by 5, you take the reciprocal. So here 1 becomes 1 over 5. So that is actually 2 divided by 5. So this, instead of this notation, if you write using this notation, 2 divided by 5. 2 divided by 5. Okay. So if you want to find the value in the decimal, it will be 2 divided by 5 is 0.4. And the last one, now here you have to follow the BODMAS rule. BODMAS bracket division, division, multiplication. So division comes first. Okay. So the next one I will give you in the note is the BODMAS rule. Okay, so here 4, the division becomes multiplication when you take the reciprocal. 5 over 3 multiplied by 10 over 6. So then here uh, we can simplify these two, both is or else you can simplify these two. But I keep this as 10 and I'll simplify these two because multiplying by 10 is easy. So here 2 in two into. Hi all, can you hear me? Please drop a message in the chat box. Okay, thank you, Sarah. Give me a minute. I will connect the Wi-Fi. It has been disconnected. Okay, now take your grade 10 textbook, page number 31, the review exercise. Okay, I'll give you some time. You have to do all the questions, starting from question number one. Okay, you guys continue this question. I will quickly go out and buy a mark, and yeah, the markers are running out. You can continue this question. I will be back in 5 minutes.
Till what question are you supposed to answer?
So I took this. Okay, so question number one. To complete the second table using the fractions in the first table. So first you have to write the unit fractions. So what are the unit fractions we have? So 1/7. and 1 over 15, 1 over 3. So these are unit fractions. And then proper fractions. So what are the proper fractions we have? We know proper fraction means numerator is smaller than denominator. So 4 over 5. Okay, and by the way, when I have given this question for students, I has noticed that 50-50 mostly students, if they write this here, they don't write that here in the proper fraction. This is a numerator where the numerator is smaller than the denominator. So this 1 over 7 is also a proper fraction. All the unit fractions are proper fractions. Okay. So here we should write 1 over 7. Then we have 5 over 7 and 4 over 9. 9 over 4 is not a proper fraction, so I write the improper. So improper fractions, first we have 9 over 4. And then 19 over 15. And 7 over 12 comes here. 1 over 15 comes here. 7 over 8. 11 over 9. 23 over 22 over 7. 1 over 3. 8 over 7. 6 over 5. Okay. So, yeah. Check your answers. Okay. So, the second question, you have a table. You have to write the improper fraction for given mixed fraction mixed numbers, and then mixed numbers for the given improper fractions. Okay. I'll erase this. Okay. So the first two half. Won't write the it's improper. So 2 into 2, 4, 4 plus 1, 5 over. Then we have 1, 3 over 5. So 5 into 1, 5 each. 8 over 3, 5, 6. 6 into 3, 18. 18 plus 5, 23 over. And here we have 7 over 2. So 2 into 3, 6 plus 1. 15 over 3. 3 into 5 is 15 and 1. Finally, we have 5, 4, 5. Okay. Right. And question number 3. We have fill in the blanks. So check your answers. So 1 over 4 is equals to 1 times, and here 4 times 3. If you multiply uh, the denominator by a number, the same number only, we multiply to the numerator. So then we get 3 over 3. B, we have 2 over 3. Here it's 12, which means 3 is multiplied by 4. That means multiplied by 4 is each. C, 2 over 7. And here in the denominator we have 14. 7 multiplied by 2. Therefore, this one multiplied by 2. 4. D, 4 over 16. So here both blank, so you can write either 2 over 8 or 1 over 4, or you can multiply even 4 into 2, 8, so 16 into 2, 30. Any of this consider E 8 over 20 is equals to, so here you have a division mark, then here you have 5. Okay, so in order to get 5, 20 should be divided by 4. So therefore the numerator also should divide by the same number, divided by 4. And if we have 10 over 12 equals to 5 over, so this divide by 2, this divide by 2. G 21 over 30 is equals to 7 divide by 3 divided by 3, and then H 75 over 100. So both can be divided by 25, 25 3, 25. Okay. Okay, then start question number 4. I'll give you a couple of minutes. You had write in the ascending order. Okay, question number 4. Write the fractions for the part in ascending order. The Roman number 1. What we have 1 over 7, 1 over 3, and 2. 1 over 7 over 3, 1 over 10, 1 over. So this is easy. So for example, you can take one pizza and divide into 7. Okay. So you take one pizza and divide between 7 friends, then you get one portion. Okay, 1 out of 7. Or you can take the pizza, divide into 3, and you take 1. So now you get a larger value. So now, therefore, this is bigger than this, obviously. So this is 1 over 7, 1 over 3. right? So you can see as the number in the denominator gets bigger and bigger, the value gets smaller and smaller. Now imagine you take one pizza and sharing among 10 of you. I mean, including your 10 friends. Okay, so then you get even smaller piece. So therefore, the ascending order will be, so this is the biggest, half. You get half of pizza, half, and then 1 over, yeah, and then you have 1 over 3, and then 1 over 7, and 1 over 10. Sorry, I had right in the ascending order. So, in fact, it's totally wrong what I have done. Has to be in there. So the smallest one is 1 over 10, right? And then 1 over 7, and then 1 over 3, and 1 over. Okay. The second question also we can do with the similar analogy or with a similar argument. So now instead of one pizza, now you share two pizzas between you and your friends, right? So here we have 2 over 5 and 2 over 9, 2 over 11, 2 over 3. So definitely you take two pizza and share it with 11, you get a smaller piece. 2 over 11, then 2 over 9 and 2 over 5, and then 2 over 3. This is the ascending order. Okay. Now the first one and second one straightforward. By looking at it at these values, we can say which is small and which is greater. Okay. But in the Roman number 3, not like that. So you have different values in the numerator and denominator. 2 over 3, 5 over 6, 1 over 2, 3 over 4. So now it's a bit complicated. Now you take 2 pizza dividing to 3, 5 pizza dividing, 1 pizza dividing, 3 pizza dividing 4. Now this one we can say, by looking at the numbers, we can say, okay, the smallest is this, and then this. But here we can't quickly think like that. It is quite difficult. For this such question, we have two methods. I'll explain you both of the methods. The first method is, what you can do is you can take the common denominator by taking the LCM of these numbers. LCM. So LCM of 3, 6, 2, 4 is 12. Okay. So then 2 over 3, to make it 12, you have to multiply by here 4, therefore this is also 4. Then 5 over 6, here 2, this is not 2. And 1 over 2, 6, here 6. And here 4 into 3, therefore 3. Okay. So then here this is 8 over 12 and 10 over 12, 6 over 12, 9 over 12. So now it's very easy. Now you take a pizza, divide into 12, you take 8 pieces. You take 8, now you take pizza and or cut into 12. You take 8, or you can take 10, or you can take 6 pieces out, or you can take 9. So the largest one you get if you take 10 pieces, right? So this is the biggest and this is the smallest. Okay. So this is the first method. So you can write 6 over 12, then after that 8 over 12, and then 9 over 12, and 10 over 12. By the way, if you leave the answer like this, you won't get marked because you need to write this fraction, not this. So therefore now 6 over 12, where it came from? It came from 1 over 2. So you write 1 over 2. 8 over 12, where it came from? 2 over 3. 2 over 9 over 12, where it came from? 3 over 4. And then 10 over 12, that came from here, 5 over 6. Okay. So therefore, this is the ascending order. The other method is you divide this and write in the decimal. 2 divided by 3. It will be, so 2 divided by 3 is equals to, I know 1 divided by 3 is 0.333. So multiply by 2, 0.666, and it will continue. We can round up to first decimal place. So it will be 67, 0.67. And 5 over 6. Okay. 5 over 6. This one I can consider as, how can I divide 5 over 6? Okay, so I divide by, I'm not getting, I divide. So 5 over 6. So 0 0.450. How many 6 are there? 8. 6 into 8, 48. Remains 2, 420. 3, 18, 2, 420, 3, 18. So 0.8333 will be 0.8. And the next one, 1 half. 1 over 2 is, we know that half. 3 over 4. 3 over 4 is, 1 over 4 is 0.25 into such into 0.75. So now you can compare the values. The smallest, what is the smallest? Half, 0.5. So half is smaller. Then after that 0.5, 0.6, 2 over 3, and then 0.7, 3 over 4, and then this 5 over 6. So there are two methods. You can do either this method or this. Totally your choice. Okay. So if you understand this, do the Roman number 4 now. I hope you can try the Roman number 4 in question. Do it. Okay, so here I'll be following the step where CM of this 5, 8, 4, and 2 is 40. Okay, so then I can write this 40, 5 has multiplied 8. So then this 4 into 8, 30, 8 into 5 is 40. So 5 into 5, 4 into 10, so 3 into 10, 2 into 20, 1 into 20 is 20. So then now I can write this ascending order. So definitely 20 over 40 is the smallest, and then 25 over 40, and then 30 over 40, 32 over 40. 20 over 40 came from one half. 25 over 40 came from 5 over 8. 30 over 40 came from 3 over 4. 32 over 40 came from 4 over 5. So therefore this is here. I hope your answers are correct. Okay, and do question number 5 and excuse me, sir, I can see your video, but it appears to be small due to some network issues. Therefore, it is not clear. It is the same scenario for others. I mean, for Afifa and the Umar, do you also experience the same problem? Afifa, can you let me know in the chat box? Afifa, is everything okay for you? And how about Umar? Guys, can you hear me? Please let me know in the chat box. Uh, do you find any issue with the camera video? I mean, the video isn't clear for you. Please let me know whether the video is clear. And if this is not clear, okay. Mm, all right, so with this concern, as the video is not clear, I'll wind up from here. So you can complete this review exercise, question number 5, 6, and the whole exercise. And in the next class, we will be discussing further questions from fractions and a few past questions. And in the following week, I mean next week, we will be doing the question from fractions, because fraction is a solid question. You will get definitely in your exam paper. You must have to do that if you don't want to do two geometry questions. So if you take last 10 years, the fraction question is there, or even you can take 15 years, the fraction question is there, the 10 marks question is there. So it is a very important part. Okay, so practice more questions from this. So you can also take this master guide. So there you can do a lot of questions. Why I'm saying to buy it, because now now you may know very thoroughly the fractions, how to do and all stuff. But later on, after 4 or 5 months, if you don't practice any question from this, then you may forget. That is a normal thing as a humans. If you don't use something, okay. Now, for example, you can not only in the max. Now you have using, let's say, your for example, a headset, pair of headset, okay? And for a certain period, now because of your exams are getting closer, you don't study, sorry, you are not using that, the headphone, and after when you again want it back, you may forget where did it be, because like that only, if you don't study, uh, you will forget. Therefore, you have to continuously have to do question. Now, if you have finished up to 4 lessons, then you have to do questions that covering all 4 lessons. Not only that, you should also practice questions from grade 9. Okay. Now, for example, binary numbers you don't have in grade 10, 11. Your binary numbers you study in grade 9. Okay. Grade 9, I think the second unit. Okay. So you can do past papers. You will see that in paper 1 part A, in some years they have asked some question from binary numbers also. Binary numbers is not there in 10, not there in 11. Why they asking? Because for your paper is made about more than 50 percentage from grade 10, and around 40 percentage from grade 11, and then remaining percentage from 9 and 8. Okay, so there are some questions you see they have given from grade 8, which is I mean goes with the grade 8 textbook course. Okay, all right, so please continuously do questions. uh, so that's all for today. If you have any questions, you can let me know. I'll check that. Any questions? Okay, I'll remove this my speak. Okay, if you have a question, you can unmute and talk. Okay,
No,
so
sir, nothing, ma'am.
I guess I'll. Sorry.
No, sir, no questions.
Okay. All right then. Study well. Take care. Bye. See you, Amanda.